Hi guys, Mrs. A here. We are looking at finding angles using trig ratios, but today we're going to do this in radians instead of in degrees. So let's get started by reading the problem that we have here. The point -12, -5 lies on the terminal arm of an angle theta in standard position. So that means the principal angle arm is going to end at the point -12, -5. So first we want to draw a sketch of angle theta. Well, that's what we always do to start off anyway, so that's what we want to do. We're going to draw this sketch just kind of roughly here so we get a visual of what's happening. So there's our Cartesian plane. If I'm doing -12, -5, I'm going to go -12 and then down to -5. So I'll do this really roughly here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's my -12 and then -5. 1, 2, 3, 4, 5. And so the point is about here, and there's the terminal arm for my angle. So when I have a terminal arm, we know we can always make a right angle triangle with the x-axis, and then we refer to that for our related acute angle. So I'm going to make here a right angle triangle. And looking at the point that we had, the -12, -5, I can now label the sides of this triangle. This one here is -12, and this side length right here is -5. Now, if you don't use the negatives on the side lengths of your triangle, because they are side lengths, that's okay, because you can refer to the cast rule at the end for the negative values on your trig ratios. But if you do them now, you won't have to worry about the cast rule later. So there's the triangle. We're missing one last side here, so we do want to calculate that last side length. So we'll call that r for the radius. Use the Pythagorean theorem to solve for that r value. So we know r squared is going to be equal to the 12. You can use the -12, it doesn't matter because we're squaring it, plus the -5 squared. Okay, so this gives us r squared equals 144 plus 25. R squared is going to be 169. And when we take the square root, r is 13. So we get a nice number there for this hypotenuse length. Now that we have all three sides of the triangle, we can do part B of the question, which is to find the primary trig ratios for the angle. So we have angle theta, we can call the principal angle right there. And the related acute angle is always this one in here, I'll call it alpha. When you do your trig ratios, it doesn't matter if I use the alpha or the theta because we'll get the same trig ratio because the related acute angle relates to the principal angle. So let's go ahead and do those trig ratios. I'll do them over here. So let's put them here. The first one, sine theta is opposite over hypotenuse. So opposite over hypotenuse. That's -5 over 13. And if you think about the cast rule, the sine ratio should be negative in that third quadrant that we're working in. So we already took care of that by having the -5 there. Our second ratio is cosine theta, and that's adjacent over hypotenuse. So adjacent is going to be -12 and then over 13. And again, in that third quadrant, cosine is negative. So we've taken care of that there. Okay, and our last one, we'll do tangent theta is opposite over adjacent. So here, opposite is -5 and adjacent is -12. So we'll have -5 over -12, which we know is positive. So we'll put it as positive, and in the third quadrant, tangent is indeed positive. So that works out. There are three trig ratios. So finally, we want to calculate the angle value of theta, and we're going to do this in radians today. But to find that angle theta, we first need the related acute angle. Okay? You can choose any 3 of your trig ratios to calculate the angle. I'm going to use the tangent because it gave us a positive value, but it doesn't matter what you use. So the related acute angle will be the inverse tangent of 5/12. Okay, so now you want to use your calculator for that value. Make sure your calculator is in radian mode because that's what we're working with now. Okay, when you do that, you're going to get 0.39 radians, and we are rounding that to the nearest hundredth. Okay, so that's the related acute angle in the drawing. So if we want the principal angle here, we'll do pi plus the 0.39 radians, because the half circle is pi radians, and then we have that related acute angle that's 0.39, so we'll add those together. So our angle here, pi plus the related acute angle, and when we calculate that, we get 3.53 radians. Okay, and again, we've rounded that to the nearest hundredth. Okay, so let's think about this now. This angle is just past the pi mark on the Cartesian plane. So if we're just past, remember that half the circle is pi radians, that's 3.14 radians. So if we're just past, the 3.53 radians makes sense. So that's a logical answer. Thanks for watching Mrs. A Loves Math.